This is Mr. Anderson for Keller Community College, looking at page 3 of the practice test for Chapter 7. And let's go into solving equations using radicals here. The first step is to get the radical all by itself, and we're fortunate that the radical is all by itself on the left-hand side. So to solve for x, the second step is to get the inverse of the square root of 4, which is going to be taking things to the fourth power. So let me go and get my pen started here. So this is the fourth power of both sides, which leaves me with x plus 5 on the left side, and the right side is 2 to the fourth power. And 2 to the fourth power is 16. 2, 4, 8, 16. Then we subtract 5 from both sides, and we get an answer of x is equal to 11. Our last step of the problem is to check our solution. So we should probably take the 11, put it back inside here. 11 plus 5 is equal to 2. And the fourth root of 16 is 2. So this checks out, so our answer is x equals 11. For the next problem, though, one of the tricks of this is that some people believe that this first term is the cubic root of 3, or the square root of 3x, but that's not the case, because the root right here is only on the x, so this is 3 times the square root of x plus 12 is equal to 9. So you'd subtract 12 from both sides, and you get 3 square root of x is equal to negative 3. Divide both sides by 3, and we have the square root of x is equal to negative 1. Now some of you at this stage can probably figure out what the answer is, but let's keep going just in case we don't see it. We square both sides because we're going to try to get the x by itself, and so x is equal to 1. Now it's important that we check our answer, so we're going to go to our problem here and go 3 times the square root of 1 plus 12 equals 9. Well, 3 times the square root of 1 is the same as 3 times 1, so 3 plus 12 is equal to 9, which means 15 is equal to 9, which is not true. In this case, what happened is in this critical step right there, we had a problem where the square root of x is equal to negative 1, which is completely impossible. So what this means is that there is no solution to the problem, so this is invalid as an answer because when we plug it back into our problem, it just doesn't work. And we have to check these for even roots, so look at this problem, which is the fourth root of x minus 2 equals 1. If I move the 2 to the other side, what I have here is the fourth root of x is equal to 3, and then we take everything to the fourth power. What we have here is we have x is equal to 3 to the fourth power, which is 81. Now if I take 81 and take the fourth root of it and subtract 2, 3 minus 2 is 1. So this does check out. And this next problem here, very similar to number 47, we're just going to move the 5 to the other side first. And so this gives me the fourth root of 2x plus 3 is equal to 3. Then we take the fourth power of both sides, or take everything 4 powers up, and then we're going to go 2x plus 3 is equal to 3 to the fourth power, 81. Subtract 3 from both sides. Sorry, my handwriting is so sloppy there. 2x is equal to 78. Divide both sides by 2. X is equal to 39. So if we go to our problem here, we'll take, just to check our answer, if we go 39 times 2, which is 78, plus 3 minus 5 is equal to negative 2. Well, this makes the fourth root of 81 minus 5 equals negative 2, or 3 minus 5 equals negative 2. It checks out, so this is our answer. So be sure to be on the lookout for number 46, a problem where you're going to have an answer but may not have a solution there. It's definitely important to check your even powers. Alright, let's take a look at these two problems here. I'm going to just quickly move those down a little bit. And that way, what I'm going to do is show you how complicated this is, because what's going to happen here for this problem, get to my key here, what's going to happen here to this problem is that we're going to need to move this, well, we can't move either of these roots over, and the reason why is because if we try moving the roots over, it's just going to put the root on the other side. So we're best to just, at this moment, just square both sides. So if I square both sides here, so this is squared and this is squared, what this is going to mean is that I'm now going to have a binomial on this side. Oops, that should be a minus there. Sorry about that, it should be x minus 6. And here's 3 plus x minus 6. And over here on this side, if I square the x plus 9, it just becomes x plus 9, because the square of the square root is just itself on the inside. Now we're going to do some FOIL. This is going to be 9. This is going to be positive 3 x minus 6 under the root. And then do this cable here. This is going to be positive 3 x minus 6 under the root. And then this last cable here is going to be just x minus 6, because the root times the root is itself equals x plus 9. Now what's going to happen here is the middle two terms are going to combine to make 6, and then we have x minus 6 under the root. 9 minus 6 is 3, and just with a plus x is there. So I combine the 9 and the 6 on this left-hand side of the equal sign, so they are now 3. The x just goes here. And now we're going to bring these two terms over to this other side by subtracting. So 9 and 3 get subtracted. X and x get subtracted. So these go away, these go away, these go away, because these make 0. And so 6 is equal to 6 times the square root of x minus 6. Then we divide both sides by 6. And what we have here is the square root of x minus 6 equal to 1. We square both sides, and x minus 6 is equal to 1. And add 6 to both sides, and we have x is equal to 7. Now for me to check my answer here, because if I'm going to plug this in here, I'm going to have 3, this is my check for the answer up above, 3 plus 7 minus 6 is 1, and that's equal to 7 plus 9, which is 16, so 3 plus 1 equals 4. Checks out. So my answer is correct. Okay, and this problem, number 50, is definitely worth its weight in gold here, because it's going to really tax us a lot in terms of our algebraic properties here. Might be worth a bonus point on some of the tests that are out there. So let's talk about how to do this. I think one strategy would be if someone would say, well, I'm just going to square both sides here, but it's probably not a good strategy. I would move the this one to the other side for the simple reason that it's going to be now positive instead of negative, and also like problem 49, it will kind of flow in the same way. So problem number 50 is going to be the square root of 6x plus 7 is equal to 1 plus the square root of 3x plus 3. It's at this moment we'll square both sides. And in squaring this side here, it just gives me what's on the inside. And here on the outside, this one here, this binomial, we're going to have 2 of them. So 1 plus the square root of 3x plus 3. 1 plus the square root of 3x plus 3. So what we're going to do here is going to do some FOIL. First, outside, inside, last. And the first 1 times 1 is 1. The outside is 1 times the square root of 3x plus 3. Then the inside, which is 1 times the square root of 3x plus 3. And then finally, the square root of 3x plus 3 times the square root of 3x plus 3 is just 3x plus 3. Because the square root times, if the two square roots are multiplied by each other and they're the same on the inside, it's just what's ever on the inside. Now what I'm going to do is kind of simplify all this on the right hand side. 1 plus 3 is 4, and I'm going to also bring the 3x over here. And then if I have 1 plus 1 of those, I now have 2 of them. 3x plus 3. So 6x plus 7. Alright, so now we are going to move the 3x to this side and move the 4 to this side here. So this is going to be minus 3x minus 4. So what we have now is 3x plus 3 is equal to 2 times the quantity of 3x plus 3. We'll square both sides because we're going to get rid of this square root. The right hand side here goes away nicely because 2 times doesn't really go away. 2 squared is 4, and the square of this square root is going to be just 3x plus 3. On this side, what we have here is we're going to take 3x plus 3 and we're going to power that up here. So we're going to FOIL this out. So 3x and 3x make 9x squared. 3x and 2 make 6x. 3x and 2 make 6x again, and 3 and 2 make, or 3 and, oh shoot, that was supposed to be a 3. Let me quick fix that. This makes a 9x here, and this makes a 9x here, and 3 times 3 makes 9. And I'll distribute this, so this is going to be 12x plus 12. Now, I'm going to move this 12x to the left side and move this 12 to the left side, and this gives me 9x squared. 9 and 9 is 18, minus 12 is positive 6. 9 minus 12 is going to be negative 3. So again, these two got combined to make a total of 18 minus 12 to make 6, and 9 minus 12 to make negative 3. Okay, so here's what I've got to do now is I'm going to now do a tricky trinomial problem after factoring out a 3, because by factoring out a 3 we make the problem 3 times easier, like so. And we now get to play the game of multiplying 3 times negative 1, which gives me negative 3. And what combination makes 2? I think that would be 3 and negative 1. So this is going to give me, let's see here, 3 x squared. We're going to split this up into 3x minus 1x minus 1. So we're going to use a bracket here. I'm going to bracketize this because I'm going to factor something out of the first two here, which is 3x. And that leaves me with x plus 1. And in my second two problems here, I'm going to factor out a negative 1. That's going to leave me with x plus 1. And I should feel good about myself because I got two parentheses inside that are the same of this 4-term factoring problem. Now I'm going to rewrite all the way back up here, and I'm going to have 3 outside a hard bracket of 3x minus 1, and then x plus 1 equals 0. Now what I can do here is divide both sides by 3 since I'm solving for x. So this gives me with 3x minus 1 times quantity of x plus 1 equals 0 divided by 3, which is 0. And then what I'll do is I'll go 3x minus 1 equals 0, x plus 1 equals 0, and solve for x. Here 3x is going to be equal to 1, or x is equal to 1/3. Here I'm going to subtract 1 from both sides, so x is equal to negative 1. Now I want you to copy down these answers, and I'm going to type these in on the calculator to check to see if they worked for problem number 50. So again, please copy these down, and now let me go to 50. Alright, let me check my work. Alright, so what I'm going to do is type in the negative 1 first into my problem here. So 6 times negative 1. I'm going to close that off there. Plus 7, and close that off. That's my first square root, minus the square root of 3, and then I'm going to put this in parentheses here, negative 1 plus 3, and close that off, and you'll see I get my answer of 1. Now I'm going to try the same thing with 1/3. So I'm going to go and type the same problem again, but I'm going to insert the 1/3 in for the 3, or in for the negative 1, and I'm going to see if I get the answer verified that way. So insert, that's just hitting second delete, 1 divided by 3, and then I delete my negative 1 from the previous problem, and it works too. So these two are both working solutions of the problem. All right, thank you very much.